Continuing with our SN1, SN2 discussion, chapter 9. Recall that deuterium is the same chemically as hydrogen. So in terms of doing Rx, that carbon has only one bond to carbon, so it's primary. So you have only one possible conclusion, which is, that's right, I don't want to see a primary carbocation. When you think SN1, you think carbocation, right? Do not give me SN1 for a primary. So same guy down here. It's going to be SN2 in your product box. Please never stop your analysis. Each line gets a point, regardless if it helps your decision or not. There's knowledge involved in each 1, 2, 3 every time. So your nucleophile. RC triple C negative. That's certainly not weak, right? Strong. So that means you just sped up your SN2 reaction, right? 3, solvent. RCO2H. Polar product, PP. Oh, guys, if you're going to use those short forms, you have to define them, okay? Polar product, you just slowed down your SN2. You can't change your conclusion on your SN2. If you try to make a primary cation do an SN1, you're in for a surprise. It's not gonna work. SN2. Green only. That means you made up your mind after green. Don't worry about color coding your exams, okay? And stereo center, and what atom ends up attached? Oh, good questions. Which of the atoms here ends up attached to the stereo center? The C next to the K is the one that was a C minus. C triple C, CH3 right there. What happens to a stereo center in an SN2? You're going to tell me what goes on the wedge and what goes on the dash. H on the wedge because we have a flipped stereo center, and D on the dash. Yep. Good stuff. This next one, I'm really trying to force you to conclude SN1. If you're concluding SN1, you're in trouble. Primary carbon can't do SN1. So I even filled in my conclusion box before. Not solvent. Nucleophiles next, right? Nu. ROH. Weak. SN1. Solvents missing. When the solvent appears to be missing. Appears. No, don't go that. I like that. She was thinking default from 141, and she said it's going to be aqueous. No, that's not how it works in this course. It's almost never aqueous in this course, right? Organic chemistry, we got to dissolve organic molecules. So when the solvent appears to be missing, the nucleophile is also the solvent. It's very common, by the way. And the process, when that's the case, it's got a name. You'll see it in other videos. It kind of says that the solvent's going to break the molecule apart. That's what the word solvolysis means. And that means your solvent is also ROH. Please don't tell me it's weak. That's not a solvent category. This is a solvent that can hydrogen bond. Polar product. SN1. Please don't write SN1 in that box. I know we can't. I already wrote SN2. Good move. Yeah. You just have a really slow SN2 in this bottom one. And in the top one, you've got a faster one. You could have made the top one even faster by picking a better SN2 solvent, right? but we're not worried about speed in a lecture class. All right, so you got to show me SN2 result from above with the O attached, right? So copy the product above, except don't copy the blue. The blue has a sulfur attached. No, it's not sulfur, it's an oxygen attached. Got my examples mixed up. Once again, the intermediate has OH, R prime, strong acid, right? A primary carbon can never do an SN1 reaction. End of song. She asked me to explain the conclusion again. If you have a primary carbon, SN1 is not an option for that box ever. All right, so we got those two there. I think that's a good end of the day. Sorry. No. We've had other, she asked, is step one the only one that matters? If you have a Mubarak in step one, then you must do further analysis. Yeah. And yeah, we have empties and versions. Yeah. Mubarak, you got to do further analysis. Sometimes step one does give you your conclusion. If it's primary or tertiary, the extremes, right? Tertiary, you're liking SN1. Primary, you're liking SN2. When it's secondary, that's when things are interesting. So you should look forward to secondary much more frequently than the others. There's more thinking involved. And you know, us teachers love thinking. I love seeing if our students are thinking.